know what was your journey as a professional and how did it make you evolve as what you are today?
Very wide question, actually. I don't know where to start, right? But the first thing, I guess, is in terms of computers, I've generally loved software and computers. I think this was even when I was a little kid. I had a friend of mine, I didn't own it, but a friend of mine owned like a Atari. I don't know if you've even heard of those kind of machines, but there's a gaming console called an Atari, and it was a lot of fun. And it also allowed us to even write a little bit of code. I'm sure I wrote crap code then, but I think I was hooked the idea that you can actually create something. And every time I chanced upon somebody's computer or somebody's laptop, right? We're talking not in this millennium, right? We are talking in the 1980s and 1990s, right? It was just something that I kind of liked, though most of my focus was on sports and jumping around and running and all of that. There was always that interest in computers and software. So when it came to choose a stream in engineering, it was clearly computers, right? I didn't have even an alternative that I wanted to choose. So that's, I think, how it started. And then, of course, the usual path for an engineer, right? At least in those days, is find a job. The idea of entrepreneurship is fairly more recent, at least for this crop of people, right? But in the 1990s, towards the end of 1990, it was typically about getting a job, and which I was lucky to have straight out of college. And then, of course, is one thing after the other, right? And here we are.
But like, what was that journey all about? Like, it was not DevOps, it was sysadmin during that time. And, system engineering was something which was profoundly said. Like, we still talk agile, we still talk Toyota production system, but what was it all about when we are talking about a scalable delivery system? Like, something like everybody's coding during that time. And what was it all about when you saw the industry? How did that industry evolve today? Of course, it has evolved in a very great fashion, but like, how did it evolve as you saw?
I might not be a right person to answer that, very honestly, like, because when you're starting out, you have very limited view of what is available, right? You just see the 2 or 3 people around you coding, you've got a few friends who are doing coding. Whereas today there is, after you reach a certain level, I mean, I'm not saying a level, as much as when you gain a lot of experience, you realize this has to be looked at a larger scale, right? You have to look at it at a large level. And I didn't have that view. And this is something maybe people shouldn't pressurize them into knowing, right? That we should know everything when we start. Pick one particular battle, maybe one small area, try to do well there, and then you can grow that knowledge. There is, of course, value in also getting that high level thing and then digging down, right? But at least for me, it was not the case, right? For me, I was writing smaller programs. So, for example, the idea of cloud, at least it became way more known only towards the mid 2000s, 2006 onwards, and then really caught on only after like 2008, 9, that era. So in the early years, it was none of that, right? We were building small applications. So, for example, in one project, I was building a Windows Wi-Fi driver. Another project, I was creating the Bluetooth stack for a headset. In certain other cases, we are building a network management system, or we're building one particular user interface in Java Swing at that time, which is a thing. And then a lot of that kind of stuff. So the idea of evolution for me would be starting small around small things that I did, right? I had practical experience on. And the shift to the cloud happened much later. In fact, it happened way after even it became popular. Because even while the cloud was becoming popular, I was not fully on it, right? Because the assignments I had, the projects I had, were not really that. And you can't be doing that on your own, at least not at that scale. So for me, the introduction to a cloud happened much later. I would say somewhere around, even though I might say 2012, 2013, it would be more realistic to say around 2015 and thereafter, right? So one of the things, again, as a point of learning for others, is there is still time to catch up and do these things, right? For me, as an older person coming to something that is very hot, right? You might initially feel, hey, there are people ahead of me, not an issue, right? Pick something that is your own area, something that you like, something that you feel an emotional connect to, and start doing that, and then it will It will be something that you can grow on. Yeah? So that would be kind of how I would it was, where I did not necessarily have a, a vision about where I was going with any of these. Right? Do the things that you're doing while you're early in your career, where you won't have even the scope of view. Right? Nobody's going to. Very difficult, at least in a very large company, to be giving you the CEO view or the CIO view. Right? And but you can build on it. Right? It's not something that should stop you. You can build on it as you go forward.
Like, what do you feel about the way we are learning cloud? Because it's a flavor today. It's totally a flavor. Like, do you know Azure? Do you know AWS? Do you know GCP? But every cloud still has the same old way of working. Like, of course, they manage it in a different way. Pricing differs, but the way we can build on all the components which are already there. Like, if you can think about like GKE,
Yeah.
AKS, EKS, still remains the same. It's just a Kubernetes which is managed by a cloud cluster.
Yeah.
And if you think of Cloud Spanner, like it's a phenomenal tool. So there are similar tools out of it. Like, we just have to just bridge the gap between it. But like, what do you feel about the way in which we are learning? Because it's like more amount of certifications, more amount of knowledge. It's not that. But way we are learning it, probably I don't feel like we are just grasping what this technology is going towards. And of course, we talk a lot of AI, ML, but cloud is something which is phenomenal over the course of time. So I just wanted your view on the way in which the world is approaching the learning of cloud, because you learned it in a very later stages, because 2006 AWS came in and everything was just moving away from all the things that we are talking today when we talk on premises. So I just wanted to know, how are we educating ourselves in the cloud space? Because that thing is yet and missing piece in the puzzle when we are educating a professional today. So I just wanted your views here.
So first thing I want to say is, when you said cloud is a flavor, just to note that it is not the only flavor of the month, right? There are a lot of things that you can be attracted to. For example, there's a lot happening in blockchain. There's a lot happening in robotics. And if people have interest in that, you should definitely do that. But at the same time, almost all of these at some point have a reference to the cloud today, right? Because almost all things have the data on the cloud. They need to have security on the cloud. So what you said is very important. It becomes central to almost anything you do. In that, on the education part, on learning, right? I see different people approaching it differently. For example, I am self-taught, right? I go, I do my things, I do projects, I do labs as much as possible and learn like that. Meanwhile, we are conducting a lot of sessions via Google, where we are going out to Google's partners, helping them learn, right? We are also doing another event starting soon. I won't say we, somebody else is coordinating it. I'm just contributing to it. So for a lot of people who are maybe just getting into the workforce, or are the early part of a workforce, right? Work professionals and not too senior professionals, there's another program for them to learn. Just know, I know, because I'm talking mostly about Google because that's the one I mostly work on, right? So there's a lot of effort from even the cloud providers to upskill the people, right? So for example, I think Google has a plan to upskill about 4 million people or something by 2022 in cloud, right? So there's effort from the cloud vendors themselves to make sure that there's an available supply of engineers, competent professionals, who can do these tasks for their customers. There are people like me who are self-taught. I see a lot of students also taking this up. Right? So even without having a professional space to work in, they're saying, how do we get ahead? How do we make sure that we are employable as soon as we get out of college, right? Those kind of things. So in terms of that, there is, again, no one path. It could be an external teaching, like somebody, an instructor-led training, or it could be something that you learn on your own. Either way, there seems to be a lot of material out there. We are not at this point struggling for a dearth of material. There's tons of it, right? The Google document, talking only about Google Cloud, at least, where I know a little more, tons of material, lots of documentation. There are books coming out very regularly, right? And some of them I'm reviewing and recommending for people also. There's something called Quick Labs that Google offers where you can do hands-on exercises. So on educating yourself, there are so many means. things that might work for people. I prefer doing a little bit of hands-on and reading a few books, right? And watching videos. So there's all of that. And of course, there are independent people like me who are creating our own content, right? For example, my channel, Awesome GCP. And I'm planning to do a lot more, right? So in terms of education and learning, the material is there. It's just the effort that we need to put in, right? And you can choose what you want. There are people who want to read more. There are people who want to watch videos. There are people who want to do hands-on. For every one of these, there seems to be available material, which is a good thing, because when people want to get educated today, they don't need to necessarily cough up a lot of money, right? Or they don't need to necessarily go to a university for 4 years. They can do it at their own pace when they want to do it, right? And that is really helpful. Even for me, if you see, right, even though cloud existed for a while, I'm a late entrant. Considerably, though I've been working with the cloud or dabbling with the cloud, it wasn't necessarily the core focus. At least the public cloud wasn't the core focus. So what, right? You still have the material. You can still be self-taught and educate yourself. So it works for everybody.
But like the way which we are talking about cloud is like you're just an API away from the AGI, but the data set is something which is very, very important today, because data set plays a huge role. But on the other side, when we think of DB, which is improvising, like we have RDBMS, we have NoSQL DB, but yet there is a whole bunch of things which different products from the same cloud gives a different feature sets for all the products which they are talking about. So I just want you to give some perspectives for architecting our solution tomorrow, because we are talking about data meshes. We had data lakes, but now we are talking about data meshes which we are yet to build. Yeah, of course, some companies have already tried doing a beta version of it. Some are improvising on all the existing architecture. But like, I just wanted your views on the database, because I'm also a big database person, because I believe in that, because tomorrow's data is the key. Like data is the key. It's not the oil, it's not anything, it's the key to your future to be unlocked. So I just wanted to know, like, how far are we realizing the fact that technology is just a meager part of it, but yet architecting it by using all the components which are really available today makes a huge deal.
It does. I mean, I don't know what more to add to it from what you said, because you have said the key thing, right? That today, a lot of the companies, the reason why they're even coming to the cloud is because of the data, right? Because all the other things like compute and all of that, they kind of get it on premise. They can do it wherever they want. They might not get the same kind of scaling, but they can get it in general, right, to an extent. But the key differentiator, I feel, is how data is changing or is vastly different from how it is handled, operated on, stored, and analyzed on the cloud compared to what you're able to achieve on-premise, right? The kind of tools that are available with clouds like Google Cloud, it's not easily available, or you cannot really provision it quickly on your own private data centers, right? So the movement of data and the focus around data is one of the key drivers to people moving to the cloud. And therefore, the things that you said, right? For example, the kind of storage you have, the kind of analytics you can do there, and today to be able to combine that data with artificial intelligence, machine learning, all those kind of things, again becomes a key driver in that movement. You take something like Spanner, right, which is a global database that spans the entire world. When it initially came out, I was like, who's going to take this, right? Given the comparable cost to a Cloud SQL, right? MySQL, a Postgres SQL, and all of that. I was like, this is costlier, right? I mean, who would take it? Turns out everybody's taking it, right? Because people want that kind of dependency and scale rather than having to put their IT team's effort into make that happen, right? I'm just adding my viewpoint to the essential fact that you said, that data is driving a lot of these things, right? So, for example, like I said, for Spanner. And the other thing is artificial intelligence and machine learning, right? When you do anything there, you need large amounts of data, large amounts of data. Where are you going to store it? How quickly are you going to compute it? How are you going to get the algorithms that are going to build your model? Today, to find data scientists and data engineers is very difficult, very, very difficult. So companies are saying, why should we be trying to do this ourselves? Why should we be trying to do this on our own data center? Why should we struggle and compete against the other big providers who are working on AI ML. Instead, why don't we just ride on whatever they are doing, right? Which is why you see a lot of people moving to Google Cloud today, because Google in general leads the world when it comes to big data analytics, artificial intelligence, machine learning. A research over there, Google leads again the world in the amount of research around AI ML. So again, data is driving that process, right? Which is why the public cloud has become even more important. There is also, again, since you mentioned data, the security around data, right? How do you bring the redundancy around data? How do you ensure backup and recovery? All of these are things that the older data centers and the private machines that you used to have just are not capable of handling the way the public cloud is able to handle, right? So I agree, right? Data are very important. The tools that are coming out very important, and some of the innovations that are available on the public cloud in places, for example, like Google Cloud, is not available anywhere else. Yeah, I agree.
Because we are now talking about serverless, because we still know that there's yet to be a lot of data to be procured. There's yet to be a lot of things to be taken place into the consideration. Like something like, okay, we have 10 models right now. How can we deploy it at scale? And we have 10 models right now. How can we architect it towards low latency? Because everybody needs to have an equal amount of experience. Like somebody can access using a computer, somebody can access using a mobile, everything. So I just wanted to just get that learning from your side, like how are we architecting these patterns out there? Because a lot of times when I read some papers or else a white paper for my company, I feel like everybody is doing the same thing, but everybody has a different approach to it. Like Google Cloud Functions is different, AWS Lambda is different, Azure Functions is different, because Azure Functions is also evolving over a course of time. So I just wanted to get that learning from your side, like how are we utilizing this? Because some people still are working with the containerized applications. Some people are still in that way in which they say that, okay, we are just want to just go cloud agnostic. So we are just containerizing the apps. Tomorrow we will just build it on some container registry and we will start working on it. So what's your view on the way we are architecting and pioneering the ways for all these technologies? Because microservices evolved as serverless and so on. So what is it all about today?
One thing that we need to just change your view a little bit on that, right? Today, there's a lot of talk about things like serverless and microservices and all. At the same time, we need to bear understanding that a lot of the older companies are not there yet. So they have got systems that are decades old, and they are also moving to the cloud. Not all of them are easily transferable to the kind of technologies we have today, right? For example, they have large VMware installations, a large number of virtual machines or individual bare metal machines that are running some kind of software. And those serverless is talked about quite a bit. Let us not forget the fact that we still need to understand how things used to be and to help them move to the public cloud, right? So the movement of VMs, the virtual machines and bare metal machines also needs to be considered. So there is a balance that is drawn between all these kind of requirements, right? The older, I won't say older, right? The still continuing way of doing things in virtual machines, and also the serverless way. On that, I feel we have a fairly good mix of these technologies, therefore, right? For the kind of new age companies that are coming in, which don't want to deal with their own setup and hardware and software patching, serverless works fine, right? And of course, in certain cases where they need to have a stateful, a stateful compute, the kind of thing that you'd find in a virtual machine, you've got that also. For example, in a hosting databases, you ideally don't do it on serverless kind of stuff. It just doesn't work very. So today, I think there is a good mix of all these available technologies, where a company choosing to either migrate from older environments or coming into the new environment have got the possibility to do either. And usually it's a mix and match of the two, right? So I don't think serverless is a panacea. I don't think serverless is going to be everything everywhere. It's great. It's great because you reduce the amount of IT effort that you have to put in, and you focus more on application delivery, right? How do I write code? How do I write code? That's basically it. and how do I make sure that the business logic is correct, more than thinking about things like scaling and connecting and all of that. This is great because what you will see is again innovation being accelerated quite a bit. Because earlier we had to worry about things like this, right? We're putting up an application, we have to think about how many servers do we need, how many people might potentially come in, and that slows down the process of feature development. It slows down the process of what we generally say go to market, right? Whether you bring in a new product or whether you bring in a new feature, um, it takes too long for that to happen, right? And today we are able to deliver this at speed, at high speed, which means that we are able to test quickly, we can get feedback quickly and cycle through this process. So I'm very positive about where we are going with this. I don't have a view about where it is going. Somehow I don't have the vision right now. I see serverless is great, but of course it has to be combined with the whole stateful, serverful idea also. So the future, I would say, looks bright for a person who has that vision. That's probably not me at this point.
Yeah, you have an inevitable love towards that Golang, because that's like you have always been preaching about Golang in a lot of your sessions and a lot of other places that you just have worked also, like OpenShift, you had used Golang. That's what your journey was all about. Like it's all about like the way in which we are architecting it. It's not like Golang can be used everywhere. It's like the flexibility that it brought on the table. If you think of Kubernetes, Kubernetes is written on it. If you think of other softwares, there are many people who are using that language and started writing it. So I wanted to realize like how far is the language a barrier today or tomorrow? Because we are coming up with our own languages. Every company has their own language. Every company has their own wrappers, frameworks, whatnot. Shopify came out with their own front-end framework called as Hydrogen. Like a lot of things. So I just wanted to realize like how far is language going to be a barrier for tomorrow? I don't know, because I just want your views.
I'm just going to answer the last part, right? The fact that there are lots of languages will always be there, right? There will always be somebody innovating, somebody coming up and saying, you know what, I want to write my own language, or I want to write my own operating system. But chances are that only a few of them will really filter, they'll bubble up to being popular. For example, you say, look at something like Linux, right? There are so many flavors of Unix, but not all of them are relevant today, right? Not all of them are used as much. You will find the same in languages also. And there will be languages that when you look at it today and you look sideways, you will see many languages being there. But if you look in the past, only a few of them will actually stand out. So for example, the key things that will stand out would be things like C, C++, Python, Java, JavaScript, right? The others, do you even know the others? I mean, I'm sure you've heard of them, right? They don't stand out at all. But I myself, over the years, I have worked on things like Fortran, COBOL, Lisp, obviously, assembly language, and a bunch of other languages, but none of them really make it because they don't really change or adapt, or they don't have the vision to kind of look for what is going to happen in the future. Another language that was very popular at one point was Ruby, right? Everybody was talking about Ruby. And today you don't hear about it very much, right? Except the existing projects that need to be maintained. Usually Ruby is not a first choice. So languages could be an enabler, or it could be something that becomes a hurdle if you don't choose right? So for example, even though something like PHP is still very popular, there are limitations to what you can do with PHP, right? There have been language, like I've written another language called Perl. Perl also has certain limitations, right? There's only so much you can do with that. There was a time when Python wasn't doing very well compared to the other popular languages like Java, C# and all. And then again, when machine learning made a big comeback, or it became very popular, again, the popularity of Python just shot up. So each language has, or the language designer has made certain choices about what we want to get from this language, right? And therefore, those choices could be both an enabler, like I said, or it could be something that disables any kind of progress. There are even popular languages today, extremely popular languages that are kind of waning off. For example, you take something like Java, right? Java slowly I mean, it's going to continue to be there for a long time, right? Because a large number of enterprise applications have been written in Java over the years. But you will see that the importance of it is slowly coming down, right? The number of people working in it is coming down. And that's because core decisions about the language don't work well for the future. Similarly, Python. Python works very well for machine learning, but you wouldn't find a lot of companies actively choosing to put Python code in production, right? So again, right, since you started the conversation about Go is a superb language which works in certain kinds of environments, right? So for example, in backend server code, Go absolutely shines, right? And today it is beating almost any other language that you can find in the area of backend server code. It has been designed with that in mind. They're the key creators of that, Rob Pike, Ken Thompson, Rob Griesmer, and the others who came together to build that language, had certain ideas about what we want in this language, what is it going to be purpose, and they made those decisions and stuck with it, right? Which is the reason why Go has done a really, really, really good job. Also the reason why I think about more than 3/4 of the current CNCF, right? The what is it? Cloud Native Compute Foundation. Yeah. Most of this project is written in Go because it is well suited to that, right? Whereas languages like Java, which were popular earlier, for example, a lot of the backend servers that were written earlier were written in Java, at least the public one. And if you have a Microsoft house, you're writing it on one of the .NET framework or IIS frameworks. So the short answer to that is the choice of language absolutely makes a difference, right? If you choose a wrong one, it will mean that either you're going to rewrite your code after a certain point in time, or you're just going to have too much effort in maintaining it, right? Whereas some languages, they have gone through the test of time and still continues to be very popular, but for certain kinds of workloads, right? C is still very popular for a lot of small, certain kinds of devices, right? When you're doing device kind of coding, but you don't find that being used in a lot of backend application code, right? Nobody uses C. So yes, the short answer, the choice of language makes a difference. And the choice of language based on its design considerations and the language governance is very important in the in choosing that particular one. I do remember at one point in time, I had a top leader in one of the companies I was working for. He was saying something like, what is this Java, man? Everybody's saying Java, Shava, it doesn't matter, right? What matters is the business, the business, right? That's what you should be focusing on. That's what is important. The language doesn't matter. And initially I thought, yeah, actually it doesn't, right? Because finally what keeps the world running is the movement of the business. But the choices you make in moving the business has an implication on the business, right? So there was a period when I thought languages are very important. Then I said, oh, maybe it's not. And now I again feel languages are the choice of language that you make for a particular kind of work that you're doing is very important.
Yeah, because even before the talk that we had right now, before the recording, we're saying about how the passport, the process in which the passport is being given to you, there was hectic. Like I still remember 2017, it took me a long time and it was stuck in the post office and I had to go there. I had to come up, and the software is evolving. So, and there is another place where abstractions are coming up. Something like TensorFlow is allowing me to do what 15 years ago MIT scientists used to do, or Stanford scientists used to do. But it all comes out with some sort of a security aspects that has to be covered, because that abstraction might be insecure. CWE, CVEs, CWS, all these things. There are different institutions for that. But when I look at something like Pulumi, it's using Go, it's using .NET, it's using Python, it's using other languages to provision an infrastructure right now. And we had domain-specific languages, we had Terraforms, and a lot of things. Are these tech that's being involved in architecting a solution today, are they going to make a huge impact tomorrow, or else what is it all about when we are talking about such provisioning of architecture using some infrastructure as a code? Because our lives are getting easy even without that as well. But is it become Is it going to make us more easier? Because I don't know, because I just want your views, because you have been seeing the tech from a very long time. So I just want your views on this.
I'm actually very much for it, right? As with any other thing, code means that we can make things consistent. We can make it also very flexible, right? So the whole infrastructure as a code movement is something that I'm entirely behind. To have to do these kind of things on our own each time, it is something we used to do, right? We used to have like labs where you have to set up a large number of machines, and a significant amount of time goes in just setting up the machine and configuring it and all. And it's not something that I want to go back to. The second thing is, of course, the scale at which we are doing it, right? Earlier, we used to have a lab, think of like a large room where there are racks of machines that we operate. We set up the operating system, we run it. Uh, it was inefficient compared to what we have today. And since everything is on the public cloud, where we have the ability to set up hundreds of thousands or hundreds of thousands of machines, right? You can't be doing anything manual. And I think the future continues to be infrastructure as a code, continues to be infrastructure as code, right? I also, in that thing, tried to get the Terraform certificate. I got the Terraform certification, which I think was good again, right? It's something that others should also kind of know, because the more time you spend trying to set up infrastructure is time that you're not spending elsewhere, right? For example, I want to spend a lot more time doing data engineering and machine learning and all that. But for that, for putting up some of those things, you need to set up the infrastructure, right? And I don't want to do that manually anymore. And I wouldn't recommend anybody else also do it. So I'm strongly behind infrastructure as code as an approach, and that everybody picks up some learning around it. And ideally, at this point, I would say Terraform is the industry leader, even though individual cloud providers might have their own tools. So for example, in Google Cloud, there's something called Deployment Manager. So Deployment Manager might be the most ahead, but Terraform is the most well-known, right? So you can just study that. And everybody should give it a go.
Yeah, last question. I just wanted to know what's in the best practices that you ever saw in the industry, and also some best projects that you worked on. Like, if you can describe that, it would be great.
That I don't know, actually. I'll have to start thinking about it, which might take time. In terms of best practices, right? Some of the things that you will see after a while is not so much going to be technical things, but it is going to be other aspects, right? For example, all the software aspects. For example, making sure that you know what the customer wants, right? To have a good idea of what is required, instead of jumping into doing something based on what you're already familiar with, right? So you will see that over a period of time, the best practices from a technology point of view are usually documented as part of the cloud providers documentation. So for example, they say, don't put public IP address. Yeah, it's fair, right? Now we understand that it's not so much, it's not an exclusive knowledge that I hold, as much as everybody has access to it, which is wonderful. The key things, like I said, would be these kind of stuff, right? Software aspects. How do you communicate better? As an architect, these are the kind of things that sometimes throws off a very technically strong person, right? The ability to communicate well, the ability to draw things out well, right? In fact, I tell a lot of people, learn a little bit of cartooning, right? Because it makes you draw diagrams very well, right? So that in a way that you can transfer that knowledge. Some of the key people that I have seen when I was working in the US for a while, there was a person who was like an architect or a senior architect, and I was like a junior person at that point in time. I don't want to name the person, but there were a few people like that who sat with me at that point in time, even when I was a dumbass, right? Who didn't have that much knowledge, right? They sat with me to tell me, hey, this is what we are doing. This is the plan. This is how we want to do it. And therefore, here is the end goal, and then choose your own steps. So those kind of things made a big impact on me, based on which then I can go learn. I can go figure out what is the right thing to do, right? So I feel the technical best practices are usually documented. Some of these other things are what you can cultivate on your own, right? How do you be sensitive to the knowledge of others? How do you be sensitive to bringing them up, not assuming that they should know what you already know, right? In the cloud field, given so much needs to be done, you can't be competent in everything. I am not, even though I've got all these certifications, my knowledge will have to stop at a certain level. I just don't have the time to do it, right? So now it's about communicating, how to make sure you bring together people to achieve some of these things. So that's on the first part of the question. On the particular project itself, I don't have anything that stands out as such, or it will be, if I say something, it might be leaking information of our customers, and that's not fair. So maybe I will skip that question. Okay.
Sure, sure. Thank you so much, Satish. Thank you so much for
Cool,
such
man.
great insights. It was awesome talking to you.